Okay, what we're filling in here is if the angle, these are the angles right here. If the angle is 0, what is the sine at angle 0? Remember, sine corresponds with the y coordinate, right? So the sine is 0. Let's move on to pi over 2, right here. What is the sine value here at pi over 2? Just 1. All right, go over to pi. What's the sine at pi? 0. At 3 pi over 2? -1. And then at 2 pi? We're back to 0, aren't we? Okay, so when you graph this, it's going to be kind of elongated quadrant 1. Looks like this, okay? And our x-axis is going to be your angles, angle thetas, okay? So 0 is here. Then we're going to go pi over 2, pi, 3 pi over 2, and 2 pi. The y-axis is either going to go from 1 to -1, because if you think about your unit circle, we don't do anything beyond 1 or -1, right? For now. All right. Now, as we graph sine, we're just going to plot our points. So 0, 0, pi over 2, 1, pi 0. 1 second. Picking right back up. All right, at 3 pi over 2, we are down here at -1, and at 2 pi, we're back at 0. So when I connect the dots, it's a smooth, continuous curve. I could keep drawing this curve to infinity. It would go on all the way from -infinity to +infinity, continuing this cycle. If you've been in physics and you learned about waves, right? It's a cycle, right?
Not yet.
Not yet? You haven't learned this yet?
Yeah.
Some people last period said they knew about it. But.
Once honors was an AP, they're going faster than APs.
Okay. Then you'll learn some terminology that'll help you in physics here in a minute. Okay, so there's your sine curve. This is like the parent function of sine. And when you see on your papers as we go along, KP, that stands for key points. And these are our key points that we need to remember for sine. And if you ever forget them, recall how we found them. We found them right off the unit circle, didn't we? So you can always go back to unit circle and recreate them. So my points are 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and then 2 pi 0. Is sine. Okay, we good to go on to cosine? Okay, so we're going to come over here to cosine, and we're going to go through the same process. Think about your unit circle, and think about my cosine values at the different angles, all right? So at angle 0, what is the cosine? What is cosine at pi over 2? It's 0. At pi? -1. At 3 pi over 2? Back to 0, and then back to 2 pi. We're at 1 again, aren't we? Okay, so it's coming back to its starting point. Now, if I graph this, it's going to look very similar as far as my xy axis. So I start at 0. I have pi over 2, pi, 3 pi over 2, 2 pi. Goes up to 1, down to -1. Then if I plot my points, at 0 I'm at 1, 3 pi over 2 I'm at 0, pi I'm at -1, 0, back at 1. So we connect with a smooth curve with arrows in the end because it is continuous. Okay. So my key points for cosine, if I list them out, I have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and then at 2 pi, 1. So far, so good? Okay, some terminology now for you. As we look at these graphs, there are two measurements that we always look at because they're cyclical, right? They just keep continuing. And so one of the things that we look at is this distance from the midline. It's always going to be the same whether it's going up or down. That distance is what we call amplitude. How high is the wave, if you will? Does this sound familiar? Yep, amplitude. How high is the wave from the midline? All right, so the amplitude of my sine curve is 1. And although this is going down, the distance from the midline is still 1. So it's always a positive number because it's distance, right? Now, the other term we need to know about is the length of the cycle. So like on cosine, it starts up at 1, it ends over at 1, but how long did it take to get there? It took all the way to 2 pi, didn't it? We call that the period. Sound familiar? Yay, good. So there's your period. That's how long it takes to start repeating itself, basically. All right? Now, what we're going to do and what you're going to be doing is taking an equation of sine and transforming it. You might be stretching the amplitude, you might be shrinking the amplitude. You might be stretching the period, shrinking the period. You might be moving the whole thing up or down, just like we've done before in the past. We just have these new 2 vocab words because they are waves. All right, so here we go. The amplitude of y equals a sine x and y equals a cosine x represents half the distance between the max and the minimum. So it's the distance from the midline. The values of the function are given by amplitude. Notice it's absolute value of a, and why is that? Because it's a distance. Okay, it's a distance. It's not going to be negative. So if I look at it, a is always that coefficient in front of the trig function. All right. So if I look at number 1, what's the amplitude of number 1?
-4.
Well, it's the absolute value of -4, which means it's 4, right? Because you have to, it's always going to be positive. So take the absolute value if it happens to be negative. Now, food for thought, that negative, just like any parent function, if it has a negative out front, that reflects it over the x-axis. Same thing's happening here, okay? Look at number 2. What's the amplitude of this one?
2/3.
Yep, just 2/3. 3, 5, and number 4?
7.
So absolute value of 7 is 7. That's all it is, as amplitude. All right, now, period. So come back to our graph for a second. So we said over here on cosine, it takes from 0 to 2 pi to complete one cycle of cosine, right? How long does it take on sine?
Same thing.
It's the same. Has to go up and down to complete a cycle. So it takes all the way to 2 pi. So both of these have a period of 2 pi. That's how we group them together. All right? They both have a period of 2 pi. So what we do when we look at our equations is, here's my formula. It's going to be that 2 pi divided by wherever b is. Now, where's b? B is located in your equation. It's the coefficient of the x value. Okay? It's the coefficient of x. That is the b that you will divide 2 pi by to find our period. Okay? So let's try that. So in number 1, let's find the period of this equation. What is b? Oops. Yeah, b is 2. So I'm going to take 2 pi, divide by 2, and I get pi. So the period is just a pi. What about number 2? What is b here? It's 1/2. So be careful when it's written like that. It's a 1/2 x, right? So b is 1/2. So period 2 pi over 1/2. What happens when we divide by a fraction? Flip and multiply, right? So it becomes 2 pi times 2 over 1. So it becomes 4 pi. So instead of taking 2 pi to complete cycle, now it's all stretched out, isn't it? Look at number 3. B here is a 3. So I take 2 pi, divide by 3. Is there anything more I can do to that? Nope. That's it. That's my answer. And then number 4, 2 over 5 is b. So I've got 2 pi divided by 2/5. So that means I'm going to do 2 pi times 5/2, right? That gives me 10 pi. So it's way stretched out. Oh, no, 5 pi. I was just checking. Good job. Pay attention. 5 pi. Can we handle this much? Amplitude period, not a big deal. So, transforming, so don't let this scare you, all right? Here's what the equations can look like. Look, we already talked about what A does, right? We talked about what B does. C, look, it's in parentheses with X. What did we say happens? Like if I gave you y equals to x minus 3, a linear equation, what would you tell me that x minus 3 is doing? It's going right 3, isn't it? Same exact principle applies here. It's just moving my sine curve opposite logic, okay? If I threw a +5 on the end of that equation, what would you tell me happens? It's an up and down shift, right? Up 5. Same thing. That's what D does. So you already know these structures. You already know what these values do. Now we're just applying it to a different shape, okay? And it gets a little hairy because we got pi's involved in our points and things like that, but it's okay. I'm going to show you I call it a shortcut. What you have to know is your key points, because every equation is going to give you different A, B, C, D values, right? You know your key points, and I'm going to show you how to apply those to the key points using this little guy right here. That looks a little crazy right now, but in their lovely 25-minute video, I'm going to break it down for you. And you're going to enjoy every moment of it, I know. Yeah, All right,